Hello and welcome to Grade 9 Chemistry. We're still following through with the following learning competency. Yeah, learning competency number 9. Use the mole concept to express mass of substances. This session is divided into the following parts: a discussion on computing for the molar mass, and then activity 3, the mass of 1 mole of a substance, and then practice on solving problems on molar mass, number of moles, and number of representative particles. You know that representative particles are the following, right? So molecules for covalent compounds, atoms for elements, and then for ionic compounds, we have formula units. Yeah. If you have to follow through with your learner's module, you can open it on Unit 2, Module 4, pages 69 to 70. Yeah, let's begin. Molar mass is it is a relatively new term in our discussion. So let's define it. Okay, so molar mass as a term is best introduced to you using this table. So suppose that you have the following materials and you have one piece of them and you measured the masses of one piece of them. So you recorded 1.7 for plastic bottle cap, 1 gram for soft drink crown, and 2.1 grams for a 10 centavo coin. And then when you counted, when you collected 5 pieces for each of them, yeah, 5 pieces sila pare-pareho, you recorded different masses. So 5 pieces, it made up 8.5, and then 5, and then 10.5 respectively for these materials. And then when you have had 15 pieces of them, your recorded mass is 25.5, 15, and 31.5 respectively. So all in all, what do you observe? Yeah, so they have different recorded masses. Despite the fact that they have the same number of pieces, you have recorded different masses for them, and I guess that concept is pretty clear for you, right? Alright, so how about we discuss the last column? The number of pieces needed to make 25 grams of plastic bottle caps is 14 pieces of plastic bottle caps. The number of pieces needed to make up 25 grams of soft drink crowns is 25 pieces. 25 grams of soft drink crown is 25 pieces. Ayan. So 1 gram each kasi siya. And then the number of pieces required to make 25 grams of 10 centavo coins is 12 pieces of 10 centavo coins. So why is that so? Again, we go back to the fact that they have different masses because they are made up of different things. Okay? They are made of different materials. In chemistry, it's pretty much the same thing. So although you have the same number of items, different objects in chemistry, different elements, different compounds will be having different masses as well. In the same way, 1 mole of different substances, so say for instance 5 pieces of different substances, they may contain the same 6.02 times 10 raised to the 23rd power, pwedeng molecules, pwedeng atoms, pwedeng formula units. But these particles, despite the fact that tagi-isang mole lahat sila, they can have different masses. Okay, that is the main point of the molar mass. Okay, magkakaiba yung mass nila, even ang mass ng mga iba't ibang mga uri ng mga examples ng mga bagay-bagay, because they are made of different materials. Okay, so ganon. That is the concept of molar mass. Now, in the following table, observe that sucrose, hydrogen peroxide, and elemental calcium with the following chemical formula with the same number of moles and same number of particles, but in the case of sugar, it's molecules, hydrogen peroxide is molecules, and then calcium is atoms. Even though they have the same number of moles, the same number of particles as well, they will be having different molar masses. So 342.34 for sucrose, 34.02 for hydrogen peroxide, and 40.08, which is also its atomic mass for calcium. Why is that so? Pare-pareho naman yung number of particles. Ito, 6.02 times 10 raised to the 23rd power molecules, and atoms. Pero why do they have different molar masses? The same thing. Okay, the same explanation for this. Okay, so kahit na para-para silang tag 5 pieces, kahit na para-para silang tag isang mole, kahit na para-para yung number ng particles nila, magkakaiba yung magiging masses nila. Okay, that is molar mass. And molar mass is reported as grams per mole. And so that is one thing that you need to remember. It's reported as grams per mole. Now, how do we compute for the molar mass? Let's have the following examples. Sample problem number 1. Say, what is the molar mass of sucrose C12H22O11? Well, you know that it's 342.34, right? That's sucrose kasi right there. Pero how was it computed? First is you get the chemical formula for sucrose, and usually I'll just give it to you, such as ito, C12H22O11. Now, what do you need to do? You identify the number of elements here and what elements are present. So in this case, you have carbon, hydrogen, and oxygen. And then you identify the number of atoms for each. Okay? So when we are talking about number of atoms, we go back to our previous example on carbon dioxide. So CO2 is C1O2. So it has 1 carbon and 2 oxygens. Same things for this. You have 12 carbons, you have 22 hydrogens, and you have 11 oxygens. So 12 atoms, 22 atoms, and 11 atoms of carbon, hydrogen, and oxygen, respectively. Now, what is the next thing that you need to do? The next thing that you need to do is to look at their periodic tables and then identify the number of the atomic masses for each of these elements. So for carbon, you can get 12, and then for hydrogen, it's 1 atomic mass unit. Their unit is AMU, atomic mass unit. And then 11 is going to be multiplied by 16 because 16 is the atomic mass of oxygen. Now, what do you need to do? AMU anyway stands for the atomic mass of carbon na lahat ng mga available isotopes niya are considered, and they're all divided depending on their relative abundance. Okay, that is for another video. Okay, pero for the meantime, that's something that you need to keep in mind. And what we did here also is that we are reporting them to the nearest ones. Okay, so just to be clear, it's intentional that we reported them to the nearest ones here. And so what you need to do, you just have to multiply them. So 12 times 12 is 144, 22 times 1 is 22 grams per mole, and then 11 times 16 is 176 grams per mole. And you notice that we disregarded these atoms of carbon, AMU mass of carbon, and we just reported it as grams per mole. Okay, so ayun, grams per mole na siya. So you add them up, again, you just get the sum, and you'll be getting 342 grams per mole. And 342 grams per mole is standing as the molar mass. Okay, again, the molar mass of sucrose, C12H22O11. Simple, right? Okay, so sample problem number 2 is what is the molar mass of hydrogen peroxide? Well, you know the answer to this, based from the previous table, but we need to, compute for it. Hydrogen peroxide is H2O2. Okay, so you have 2 atoms of hydrogen and 2 atoms of oxygen. And hydrogen and oxygen has the following atomic masses. Hydrogen is 1, and then oxygen is 16. Okay, so you just write them up. And then you multiply them, you'll be getting 2 and 32 respectively for hydrogen and oxygen, but this time you will be putting grams per mole because you're computing for the molar mass. You add them up, what you'll be getting is 34 grams per mole, and that is the molar mass for hydrogen peroxide. Ayan, di ba? But this is actually more simple compared to sucrose because it only has 2 atoms. How about only 1 atom, such as calcium? So calcium is elemental, so kaya ganyan lang yung naging chemical formula niya. It's just the elemental symbol. So you only have calcium, and you only have 1 atom of calcium, and calcium's atomic mass is 40 AMU. It's the mass of calcium. So we multiply 1 by 40. You are going to put grams per mole as the unit, and you'll be getting, you're not actually going to do anything about it, just report it as 40 grams per mole. Ayan. So again, we are reporting these to the nearest ones, kaya ganyan sila. And so we're done with our discussion for the computation of the molar mass. So I hope that you kept up. Okay, so we had 3 sample problems, and I hope that you were able to note the process. Okay. The next part of this session is activity number 3, the mass of 1 mole of a substance. So now, say for instance, you were given 1 mole of a particular substance. Gaano kaya siya kabigat? Okay, but you know that 1 mole of a substance has 6.02 times 10 raised to the 23rd power particles. But how heavy will that substance be? That's a question. Okay, so, halimbawa, parang ganito rin, binigyan ko kayo ng 5 pieces 5 pieces, 1 peso coin. Okay, that's 5 pieces. Okay, but how heavy will those be? That's a question. So the objective is for you to be able to compute for the molar mass of some common substances. Okay, so the materials are the following: paper and pencil. So I would like you to complete the following table. So sulfur or azufre, leather tinga, copper tanso. What you need to do is to put their symbols, okay, put their masses in AMU or in grams, and then put their molar masses, okay, in grams per mole. And then for the compounds naman, you are given the following: water, table salt, and table sugar. They have the following chemical formulae: H2O for water, NaCl for table salt, and C12H22O11 for table sugar. It's sucrose. So you pretty much know how to solve for its mass and for its molar mass. Okay, so yeah, grams per mole ito naman in AMU or in grams. And so compute for them. I'll give you a moment. If you need more time, you can just pause this video. If you have decided to continue, let us now proceed with the following questions. Okay, question number 1. Do you think that 1 mole of different substances will have the same mass? It's a trick question. If you need more time, just pause this video. If you have decided to continue, let us proceed with question number 2. Will 1 mole of water have the same number of molecules as 1 mole of sugar? Ito, 1 mole of H2O, will it have the same number of molecules as 1 mole of C12H22O11? Pause this video if you need more time. If you have decided to continue, let us proceed with question number 3. Now, the question is, will 1 mole of sulfur or azufre have the same number of atoms as 1 mole of copper tanso? And so if you need more time, just pause this video. If you have decided to continue, let us proceed with, I think the answers na. Ayan. So the answers are the following. So for sulfur, lead, and copper, we have S, Pb, and Cu, respectively. Their masses are the following: 32, 207, 64, reported to the nearest ones, respectively. And then their molar masses are the same digits. We have 32, 207, and 64, respectively. And then for the compounds, you have the following masses: 18, 58, and 342, reported to the nearest ones, respectively, for water, table, salt, and sugar. And then their molar masses, we have the same digits. We have the same numbers: 18, 58, and 342 for these compounds, respectively. So, I hope that you were able to deduce now that when we mean mass, we actually mean the molar mass too. At least for the purpose of these discussions and for the purpose of the content of your curriculum guide, this is the principle we are going to accept. Okay, so when we mean mass in AMU grams, we also mean that to be the molar mass of these substances, be it an element or a compound, covalent or ionic. So the answer for the first question is they won't be having, of course, the same number of the same mass, but they may have the same number of particles. Again, iba-ibang substances kaya kaya they're really bound to have different masses. Parang yung plastic bottle cap at saka yung soft drink crown. Ay, kahit na 5 pieces pare-pareho sila, pareho yung mga particles nila, magkakaiba naman sila ng masses kasi nga they are made up of different materials. The answer to question number 2 is yes, both will be having the same number of molecules, 6.022 times 10 raised to the 23rd power molecules. And then, it's the same answer actually. It's similar to the answer to question number 3. It's 6.022 times 10 raised to the 23rd power atoms. And yeah, the answer is yes. Again, so I hope that you keep that in mind. You don't forget that. So we're done with the second part of this session. Activity number 3, the mass of 1 mole of a substance. Remember that, okay, tandaan mo yun, that when we mean the mass of an element or the mass of a compound, we also mean it, they are molar masses. Ganun siya kabigat. Okay? Okay, so this last part is a practice on solving problems on molar mass, mass, number of moles, and number of representative particles, such as molecules, atoms, and formula units. Okay, so let's have the following sample problem. Sample problem number 4. Okay, what is the molar mass of iron 2 sulfate, or FeSO4? So you know the drill. You just have to try. How about you try and do it by yourselves? Okay, so I'll be giving you time. You can pause this video. If you have decided to continue, that means you are done solving for the molar mass of iron 2 sulfate. I am assuming. Okay, so your first thing you need to do is, of course, write FeSO4 as your givens, and then identify the elements that are present. So you have iron, you have sulfur, and oxygen. And then after identifying the kinds of elements present, you have to count the number of atoms present for each of the elements. So you have the following: 1 atom for iron, 1 atom for sulfur, and 4 atoms for oxygen. Very good. Okay, and then you need to consult your periodic table because you need information on the atomic masses for it. So the following are the atomic masses for these 3 elements. So you have 56 AMU for iron, you have 32 AMU for sulfur, and 16 AMU for oxygen. This is quite more familiar kasi napaka-common ng oxygen sa mga examples natin. And what you need to do is you multiply them to each other to get 56, 32, and 64 respectively. Make sure that in these processes, simple lang siya. You don't overlook the importance of making sure that your digits are properly pressed sa mga calculators niyo, if you're using calculators. That's the danger of using calculators kasi minsan we think that it's so easy to use that sometimes we overlook being careful, okay? The importance of being careful in using a calculator. So just make sure that whatever you're pressing there, it's the correct digit. Now you add them up and you'll be getting 152 grams per mole of FeSO4. So what does that mean? 152 grams is the measure, it's the mass of FeSO4 per mole. So this is 1 mole of FeSO4. If we are referring to 2 moles of FeSO4, we need to multiply 152 by 2. And what will that be? So yeah, you multiply by 2, you have 4, and then 0, and then 1. You'll be getting 2. Yan. So 302. Tama ba? Yeah, 304. Yan. 304 grams per 2 moles of FeSO4. Ganun yung logic niyan. Okay, so ibig sabihin nito, 152 grams yung bigat niya kada isang mole. Kada isang mole. Okay? Ayun. So next sample problem is what is the molar mass of ethyl alcohol, which is C2H5OH. Okay, so I'll be giving you time to solve for this. If you need to, you can now pause this video if you're ready. If you have decided to continue, let us proceed with solving this problem. Okay, first you report C2H5OH as your given, and then you identify the number of atoms for each of the elements present. So you have just carbon, hydrogen, and oxygen. So we're counting hydrogen here as 1. Okay, so 5 hydrogens right here and 1 hydrogen right there will make up 6 atoms of hydrogen all in all. And then you consult your periodic table for you to know the atomic masses for each of these elements. And then you multiply them to get the following products, and then you add these products up, and the sum will be the molar mass for ethyl alcohol. 46 grams of ethyl alcohol makes up 1 mole of ethyl alcohol. Okay, I hope I made myself clear. Okay, that's 1 mole of ethyl alcohol. So question, gaano kabigat ang 2 moles of ethyl alcohol? Okay, that will be 92 grams. Very good. Okay, 92 grams. You just multiply this by 2. That is 92 grams per 2 moles of ethyl alcohol. Yeah. So this means again that yan. So I just did the explanation right there. Okay. Next is sample problem number 6. Okay. How about it? Compute now for the mass of ammonia, NH3. You can now pause this video to get more time. If you have decided to continue, let us now proceed with solving for this problem. So NH3, it has nitrogen and hydrogen with the following number of atoms, and then their atomic masses are the following. You multiply them, you'll get the following products, and then you add these to get the sum, 17. That means there are 17 grams per 1 mole of NH3. Very good. I hope that you got the correct answers. Next is sample problem number 7. What is the molar mass of citric acid, or C6H8O6? So I'll give you more time I'll give you now the time to pause this video whenever you're ready to get more time, of course. If you have decided to continue, that means you have the answer now to the molar mass of citric acid. First is you report of course, the compound. It's C6H8O6, and the number of atoms, okay, are present now. And you also put the next thing that you need to do is to write down the atomic masses for each of them. You multiply them to get the following products, and you add the products to get the following sum. 176 grams of citric acid makes up 1 mole of citric acid. Okay, I hope I made myself clear. Okay, now we continue with sample problem number 8. Okay, so the question is, what is the molar mass of aluminum hydroxide? And for this example, medyo siguro kakaiba yung, ayan, wait lang, kunin ko yung laser pointer. Ayan. Medyo kakaiba yung yung chemical formula niyan, no? Kasi it has more parentheses than usual. Okay, so aluminum hydroxide is symbolized by AlOH tapos 3. Okay, remember, when counting the number of atoms for oxygen and hydrogen, what you need to do is to multiply 1 by 3. Okay, so that's how you do it. Okay, so that means when you report aluminum hydroxide, the number of atoms are going to be multiplied by 3. So that's 1 times 3. That's 3 atoms for oxygen and 3 atoms for hydrogen. And then the usual, you just have to look at your periodic table and see what are their atomic masses. So the atomic masses are the following: 27 AMU, 16, and 1 AMU, respectively, for aluminum, oxygen, and hydrogen. What you need to do is to multiply these together, and the products are going to be added up to get the molar mass for aluminum hydroxide, which is 78 grams per mole. Again, that means there are 78 grams. It weighs, okay, aluminum hydroxide weighs 78 grams per 1 mole. If you have 2 moles, then 78 grams, of course, is going to be multiplied by 2. Okay, so ganun lang yung concept na. So let's move on to sample problem number 9. Okay, so for this, you need to compute for the molar mass, for the mass, and for the number of particles of 2.5 or 0.25 times 10 raised to the first power moles of carbon dioxide, or CO2. Okay, so first is you need to get the molar mass for carbon dioxide, which is a process that is all too familiar for you already. So first is you write CO2, and then you get the number of atoms for each of those elements for carbon and oxygen, and then their atomic masses based from the periodic table, and then you multiply them, and the products are going to be added. You'll get 44 grams per mole. So it means carbon dioxide weighs 44 grams per 1 mole of carbon dioxide. Again, so that's the first part of the solutions. So tapos na tayo sa letter A. We now move to the mass of carbon dioxide. Now, how heavy is 2 moles of carbon dioxide? Well, you know that 1 mole, 2.5 moles of carbon dioxide, you know that 1 mole of carbon dioxide weighs 44 grams. How about 2.5 moles of it? So basically, you're just going to convert. First is your given is going to be, of course, 2.5 moles of carbon dioxide. And then your table of equivalence is going to be 44 grams per 1 mole. So, syempre, yung given, may lalagay muna siya dito, 2.5 moles of carbon dioxide. And you multiply that with the table of equivalence, which is, anyway, yeah, before I forget, whenever we use this approach in solving problems, we always treat numbers as whole numbers dito sa may bandang unahan. And we put over 1, okay? Just to signify that they are proper fractions. So, merong numerators and mayroong denominators. Ayan. So, and then you're going to multiply that by 44 grams of carbon dioxide over 1 mole of carbon dioxide. This is the same thing as 44 grams per mole of carbon dioxide. Okay, pareho lang siya. Remember, 44 grams of carbon dioxide means 1 mole of carbon dioxide. Ayan. And then you need to cancel out units. Ayan. And then yung unit na matitira mo is grams of carbon dioxide. So you basically just have to multiply 2.5 by 44, and then you'll be getting 110 grams of carbon dioxide. So ibig sabihin, kapag pala 2.5 moles yung meron ka na carbon dioxide, ganyan yung magiging mass niya. Okay, so that's 110 grams of carbon dioxide per 2.5 moles of carbon dioxide. That is how they are equated. And that fraction can be simplified, and you will be getting 44 grams per mole. And we move on to the next part of the solution, which is for letter C. We need to calculate the number of particles for carbon dioxide. So since carbon dioxide is a covalent compound, we can't use formula units because that's for ionic compounds. And we can also use atoms because that is for elements. What we can use is the number of molecules. Since again, carbon dioxide is a covalent compound. And you know that from the past lessons that 1 mole of carbon dioxide, which is a covalent compound, is equal to 6.022 times 10 raised to the 23rd power molecules of carbon dioxide, right? Okay. So you'll be using that as your table of equivalence in solving for the number of particles na mayroon yan ang carbon dioxide. Since given na ang 2.5 moles, okay, that's what you need to use. We turned 2.5 into 0.25 times 10 raised to the first power moles of carbon dioxide so that it's easier to process it because 6.022 times 10 raised to the 23rd power is expressed in scientific notation. And para mas madali siyang i-process. Ngayon, this table of equivalence, of course, since we're looking for the molecules of carbon dioxide, we're going to put this as the numerator and then this part as the denominator. And so, again, it's equated as a whole number, so that's a proper fraction, and then you cancel out like terms. What you need to do when it comes to multiplying these numbers is you just have to multiply 0.25 by 6.022. Okay, the product is going to be expressed as the base number. And then for the exponents, what you need to do is you just have to add them up. Since they are both positive, that's positive 1 plus positive 23. It's a simple addition, so that's going to be 1.51 times 10 raised to the 24th power molecules of carbon dioxide. And so, ganun siya nakukuha. So, we're done with Chemistry 13. This session was divided into the usual three parts. Discussion of the computing for molar mass, an activity number 3, the mass of 1 mole of substance, and then a practice on solving problems on molar mass, number of moles, and number of representative particles, molecules, atoms, and formula units. We're still in the process of finishing learning competency number 9. Okay, this is the knowledge catalog, and I hope that I'll be seeing you in Chemistry 14 because we have more examples in that video lesson. This is Sir Carlos, and I hope you'll see you soon.